come the giant desert worm has no eyes? And why shouldn't your lava-dwelling crab be furry? Evolution has the answer to that, and so much more. Whether you're designing dragons, aliens, or swamp-dwelling slugs, understanding evolution in both fantasy and science fiction can ground your species in reality and make them feel like part of the world's natural pattern. In today's episode on World Building Sentient Species, we're diving into that topic, how evolution can be a powerful tool for building fantastical species, both sentient and non-sentient, in your fantasy and science fiction worlds. Welcome to Just-in-Time World Building with your host, Marie Mullaney. So, why should you use evolution? After all, we're talking about fantastical creatures, magical beings, divine monsters, creatures shaped by gods and myths. And yes, that's a valid approach. We'll absolutely cover those kinds of metaphysical or mythic creation later in this series. But in today's episode, I want to focus on populating your world with creatures that feel like they naturally belong in this environment. And that's where evolution shines as a tool. Evolution is an engine of biological diversity. It explains why a creature looks, moves, and behaves the way it does. Even fantasy creatures benefit from that kind of logic and consistency. Because here's the thing about readers. We are pattern-seeking creatures. Evolution has made us that way. We look for patterns even where none exist, and we find them. And when your world building supports those patterns, when your species feel like they arose naturally from your imagined environment, your world becomes more immersive and believable to readers and players alike. Evolution doesn't limit your creativity. It enhances it by anchoring the weird and wonderful in a system that feels real. So let's talk about the first step in using evolution through understanding natural selection, adaptation, and pressure. So one of the first things to understand about evolution is it's not about evolving to some kind of perfection goal. It's not about producing the strongest, the smartest, or the most awesome creature. Evolution is about one thing: the continued survival and reproduction of genes. The traits that get passed down aren't necessarily the best, for whatever definition of best you want to use. They're the ones that worked well enough to survive and reproduce under the environmental circumstances. Nothing makes this clearer than insect evolution. Take the praying mantis. In many species, the male stays still while the female eats him from the head down after mating. Why? Because by allowing himself to be eaten, he gives her nutrients needed to produce more viable offspring that carry his genes. Over time, males that didn't resist being eaten were more likely to successfully pass on their genes. And so, natural selection favored that behavior. Not because the mantis decides to be eaten. This isn't the conscious choice of the mantis going, yeah, baby, eat me, eat me. It's because not resisting led to greater reproductive success. And that's all evolution cares about. At a high level, and I am not an evolutionary biologist, so this is broad strokes, Evolution happens through genetic variation and selection pressure. Every organism has slight genetic differences, mutations, adaptations, quirks, and so on. Some of those differences make it easier to survive and reproduce. Those genes are more likely to be passed on generation after generation, and over time they become part of the species' genetic blueprint. Let's take a real-world example: human skin color. It is likely that our skins were pale under our fur back when we still had full body fur, like most mammals are, right? But as our ancestors lost body hair, probably in response to needing better cooling systems through sweat glands, they were exposed to UV radiation, especially around the equator. Now, too much UV radiation while the woman is pregnant can damage the fetus. So those women with darker skin with more melanin had better reproductive success. The genes for darker skin spread through populations living in high UV areas. But when groups migrated north into areas with less sunlight, another problem arose: vitamin D deficiency. Without enough sun, without enough UV, children developed rickets and didn't survive into adulthood. Lighter skin that could absorb more UV became the solution. Over generations, skin tones lightened to adapt to lower sunlight environment. This is absolutely evolution in action. There is environmental pressure, which creates a problem, and the genes that most successfully help us overcome the problem are the genes carried on to the next generation. Another key concept in evolution is niche occupation. Every species fits into an ecological role: predator, prey, scavenger, grazer, parasite, symbiote. And these roles exert evolutionary pressure on each other. Predators shape prey. Faster cheetahs lead to faster antelopes. Parasites shape hosts. Immune responses drive co-hunter adaptations. Scavengers evolve around unpredictable food sources, like the deep-sea creatures that rely on whale falls for sudden bonanzas in nutrients. And if you want to know more about that, I made a video about it. Check it out in the information card. These niches create co-evolution, species shaping each other's development over time. And of course, you also want to consider environmental pressures, as we just spoke about: Arctic cold versus tropical heat, aquatic versus aerial environment. In speculative fiction, high gravity versus zero G, and how that changes the creatures that evolve in that environment. For example, high gravity might lead to squat, low-to-the-ground creatures with very thick bones, while low gravity could result in floating, drifting organisms with wide surface areas. Finally, let's take a look at two examples of evolutionary development to cement the concepts we're going to need to use evolution in world building. First up, wings. Wings didn't start as wings. They likely began as simple gliding flaps, extra skin between limbs that allowed for longer jumps. Those that glided a little further escaped predators more often and passed on their genes. Generation by generation, those flaps became more specialized, eventually forming wings. And you could still see the intermediate step in flying squirrels, which have the glide form of their little flaps, allowing them to jump further. In the bird lineage, it went much further, completely transforming their forelimbs into wings that can keep them aloft. Another example to consider is the eye. The eye likely began as a small patch of light-sensitive cells. just enough to detect day versus night. Over time, that patch deepened into a sort of a lens and became more focused and eventually developed into the camera-like eye we know today. And this didn't just happen all at once. Eyes evolved multiple times over different lineages, and you can still see the pinhole eyes in some sea species. So, how do you apply this to your world building? Let's say you want to create a creature that has an electricity sensing organelle, the way sharks do. They really can sense changes in electrical current. You can Google it. Our world is freaking amazing. So, let's say you want to do that. Don't just slap that feature onto a creature and call it done. Instead, ask yourself, what problem did this feature solve for the creature? What steps did it take to reach its current form? What pressure made this tray advantageous? In the case of sharks, evolutionary biologists believe electroreception evolved as a way to detect prey under sediment or to navigate using Earth's magnetic field. Their organs, called ampullae of Lorenzini maybe, allow them to sense faint bioelectric fields generated by muscle contractions, heartbeats, or even the weak electrical fields created by ocean currents interacting with the seabed. So, if you want to add a similar tray to your fantasy or sci-fi species, sketch out a very simple 3-step evolutionary process. What is the original tray? A basic sensitivity to ionic changes in water or ambient static charge. What was the selective pressure the species needed to hunt prey that hides, camouflages, or burrows? What was the intermediary stage? Slightly enhanced nerve clusters in the snout that detect disturbances in the electric fields. And what is the final tray? Specialized electroreceptors that allow the creature to see hidden organisms by sensing their electrical signatures. You don't need to do a full evolutionary tree, and nor should you. You will be world building literally forever. You just need a kind of evolutionary logic to apply. This gives your species depth and believability, even if you never have to spell it out in the story. It feels right to the reader. And that's the power of evolution in species design. Side note, to all the people who say hard magic systems remove all of the wonder from a world, hard disagree. The fact that I know why sharks can sense electricity doesn't change how freaking awesome and wonderful that fact is. I love it. I love knowing how it works and that they could have evolved such a marvelous thing. Just because you know how something works doesn't mean it's not awesome. Just before we continue with Anatomical Realism, allow me one moment to pitch Worldbuilding Blueprints Volume 1. This book is amazing, if I do say so myself. It's got 3 unique models for building cultures, economy, and magic technology fantasy of a society. It includes over 50 worksheets, beautifully laid out in either full cover for the hardback or black and white for the paperback to help you keep track of your world. It is currently in the preview phase of Kickstarter, and you can click on the notify button to know when it launches and to back the project within the first 48 hours. All backers who back the project within the first 48 hours will have their names added to the book. So check all that out on the links below. Alrighty, and now, on with the show. So, let's talk about anatomical realism. Because there's a real temptation in world building to just slap a pair of wings onto something and call it a day. Take dragons, for example. Most Western-style dragons are six-limbed, 4 legs plus 2 wings. But in real evolutionary biology, six-limbed vertebrates simply don't exist. Not in our world, anyway. Reptiles, mammals, birds, we all have the same basic blueprint. 4 limbs. You do get 6-limbed creatures, but only among the insects. Think of dragonflies or beetles. They don't exist among vertebrates. So, creatures like the pegasi or the dragon or so on, these are fantastical creatures, not evolutionary ones, because there's no supporting evolutionary creatures around them, or at least not enough, unless they're all actually octopi. All dragons are octopi. That is now my headcanon. Anyway, if you actually want to have dragons or pegasi or so on occurring naturally, you need to have mammals with 6 limbs or reptiles with 6 limbs, because then they can have their 2 limbs plus wings, and it's part of a logical lineage. Even centaurs, by the way, have got 6 limbs. You can see this kind of world building with an evolutionary basis in several examples. In Anne McCaffrey's Dragon Riders of Pern, the dragons are genetically engineered from native fire lizards, who are small 6-limbed creatures that already exist in Pern's ecosystem. In Daughter of the Empire by Raymond E. Feist and Janny Wirtz, there are 6-limbed creatures that evolved naturally in some regions that resemble centaurs. And the presence of, but this whole world is populated with 6-limbed creatures. Even the Nidra who pulled carts are 6-limbed creatures. And this makes those centaur creatures with their 6 limbs internally consistent. So, if you're aiming for naturalistic creature design, ask yourself, how many limbs do your creatures have, naturally speaking? And which set of limbs do you then take and transform into your feature, like wings or an extra pair of hands or whatever? Are there other species in the same genus or phylum that also have the same amount of limbs? The same logic applies to sensory systems, by the way. These evolve in response to environmental pressures. Echolocation in bats and dolphins develops in low visibility environments. Heat pits in snakes help detect prey in darkness. Electroreception in sharks evolved to detect the faint bioelectric fields of hidden prey. Even in fantasy, these systems feel grounded when they're shaped by need. And always remember, constraints make creatures more believable. No creature gets everything. Evolution is full of trade-offs. Let's go back to that mantis bloke getting his head bitten off. He gains reproductive success by allowing himself to be eaten. But the trade-off is, well, he gets eaten. The gene survives, but the individual doesn't. That's how evolution basically works. Benefits balanced by cost. So when you design a creature, ask yourself, what is the cost of this trait? What did the creature give up to gain this ability? And that's the core of anatomical realism. If you're building your species through evolution, their bodies need to make biological sense. If you're going for the rule of cool and using magic or divine creation, that's fine. But know which model you're working with. Next up, let's talk about speculative evolution and how it can enrich the history and strangeness of your world. Let's play a game of what if. What if Earth's oxygen levels had never dropped? Back in the Carboniferous period, oxygen levels were much higher than they are today, like way, way, way higher. 35% compared to today's 21%. During that time, giant insects thrived. There were dragonflies with wingspans a meter wide, millipedes the size of dogs. So, what if that never changed? What if giant insects remained the dominant form of life? Maybe they developed hive-based intelligence. Maybe your world's equivalent of humans isn't the primate at all, but a colony-minded species descended from eusocial wasps or ants. I made a video about creating eusocial cultures. Check that out in the information card. Anyway, that's the power of speculative evolution. It doesn't just explain how life is now, it asks how life could have been or how it might become by changing one condition and following the consequences. What if the asteroid never hit and the dinosaurs never went extinct? Would there be a civilization of velociraptors running around with guns strapped to their chests? What if an ocean-dwelling species developed tool use and intelligence before land animals ever evolved and we never left the ocean? What if trees, through chemical signaling and root network manipulation, evolved to dominate not just forests, but animal minds? All of these ideas start with the same foundation: evolution plus divergence. You take a real-world branching point and ask, what if the branch had gone a different way? But speculative evolution isn't just about the future. It also gives you tools to imagine your world's past and how that shapes its mythology. For example, some anthropologists believe that the unicorn myth may have originated from the Elasmos theorem and a real Ice Age megafauna. It was a massive shaggy rhinoceros with a single horn that roamed the Eurasian steppes. Early humans may have encountered these creatures and passed down exaggerated stories over generations, eventually giving rise to the idea of a single-horned beast of purity and mystery. This isn't just fantasy, it's how real myth evolves from real biology. We've even had bizarre creatures like the Helicoprion, a prehistoric shark with a spiral-toothed jaw that looked like a circle saw. Imagine what kind of ancient sea legends a creature like that would inspire in your fictional world if people encountered it. So, ask yourself, what creatures once roamed in your world? Did they leave behind bones or fossils or perhaps cave paintings that has inspired a whole wealth of mythology amongst your sentient species as they look at these remnants of these creatures that came before? Do those stories still influence the culture, the religion, or the art of your world? Evolution, especially speculative evolution, isn't just science. It's also myth-making fuel. It helps you populate not just the world, but the deep time behind the world. And it gives your people the echoes of a biological past to wonder about, just like we do with dragons, unicorns, and leviathans. But here's the thing: speculative or real or a mix of the two, believable ecosystems are still the key to designing great fantasy worlds. Even dragons need something to eat, something to compete with, and somewhere to poop. So let's talk about creating ecosystems. I have created a full video on this topic, which you can check it out in the information card. But let's revisit the core ideas here, especially through the lens of species evolution. A creature never evolves in isolation. Every species is part of an ecological web, and to make your world feel alive, you need to build that web too. At the foundation of every ecosystem are trophic levels, the layers of who eats what and how energy flows through the system. Here's the basic structure. You have producers. These are organisms that create usable energy, like plants converting sunlight through photosynthesis. In a fantasy or sci-fi world, your producers might use other energy sources like radiation, chemicals, or some form of magic. However it works, there must be something that takes ambient potential energy of a sort and converts it into usable energy. Primary consumers are herbivores or grazers that eat those producers. So you've got your plant and you've got your herbivore, or you have your chemical synthesizer and you have your thing that eats it. Secondary consumers are carnivores and omnivores that eat the grazers. So they get their energy second-hand. And then decomposers are your fungi, your bacteria, your scavengers, creatures that break down dead matter and return nutrients to the environment. Even in fantastical worlds, these roles still matter. You want your food chains and energy cycles to make sense because readers feel when something is missing. You also have to think about population balance. You can't have an apex predator without a viable prey base. And if you remove the predator, your grazers might overpopulate and strip the landscape bare. Some real-world mass extinction events may even have started this way, imbalances that spiraled out of control. Here's a strange but true example. Some scientists believe that early trees contributed to a mass extinction event by pumping too much oxygen into the atmosphere. And nothing else had evolved to cope with this amount of oxygen in the atmosphere. On top of that, when those ancient trees died, nothing could decompose them yet. So they just piled up, sank, and over millions of years turned into coal. So yes, the Industrial Revolution was fueled by forests because there weren't decomposers to eat them yet. And now, well, when a tree falls in a forest, it doesn't matter if it makes a sound or not. Decomposers are waiting to turn it into energy and life again. So when you're designing an ecosystem, there are some key considerations. Carrying capacity. How many organisms can a given environment support before it starts to unbalance? Energy conversion. What's your equivalent of sunlight that is turned into some kind of nutrient? Or what is your equivalent of chemical nutrients? Balance. Who controls overpopulation? Who gets outcompeted? How is your population maintained? Also think about symbiosis and interdependence. Pollinators like bees don't just support themselves. They shape the entire reproductive cycle of plants. Gut bacteria inside a herbivore might help it digest tough flora. You can even imagine a more fantastical bond. Maybe your giant beast carries a colony of living fungi on its back that protects it from parasites. Or maybe the fungi direct its behavior in return for nutrients. Let's say you've invented that six-legged plains grazer. Ask, what plant does it eat? What does that plant convert into energy, sunlight, radiation, or magical residue? What predator hunts that grazer? And what scavenger feeds off the predator's corpse at the end of its life? What happens when those grazers overpopulate or when they go distinct? What is the impact on the ecology? When your world has this kind of logic built into it, it gives your readers a sense of pattern. Everything in the world is connected. It doesn't just make the world feel real, it makes it feel alive. Evolution doesn't design individuals. It builds ecosystems. Those are the reasons why using evolution in your species design can level up your world building. Think of speculative evolution as a biological backstory to your world. It's the scars that hint at past battles in your world. It's the vestigial limbs that no longer serve any purpose, but still exists on your creatures. It's the inherited traits that whisper of the ancient ancestors. These details add richness and history to your creatures, even if you never explicitly explain them. And don't forget, cultural evolution often parallels biological evolution, and we'll explore that more in an upcoming episode on sentience and society, where we'll look at how intelligent species evolve not just physically, but socially and culturally as well. That said, the rule of cool is absolutely still valid. I have a land-dwelling creature in my world that has an electricity sensing organelle. Why? Because I thought it was cool. So I built in ambient electric currents in its desert environment to support the concept of this creature developing that organelle. Because here's the thing. Earned weirdness always lands better with readers. If I only had one creature that could sense electricity, it might feel a little bit out of place. But it's not just one creature. It's part of a broader ecological pattern in that part of the world. And patterns are what make readers believe in your world, even when it's full of fantastical elements. So the next time you design a creature, ask yourself not just what it looks like, but how it came to be. Let me know in the comments what creatures you've evolved in your world and what evolutionary paths brought them into being. And while you're down there, make sure that you're subscribed, because in the next episode, we're diving into building fantastical species that blend biology with pure imagination. If you've enjoyed this episode, hit the thumbs up button and leave an insect emoji in the comments down below to let me know you made it to the end of this monster. A huge thank you to all of my members, especially the just-in-timers of the Build It in Stone level. Neil Buckley, A. Wellyard, Necromancer JM, Epic, Katie Kofimag, and Tony Lamano. You guys make it possible for me to produce these videos and keep upping the quality. If you'd like to support the channel, one free and extremely powerful way is to simply watch another video, because then the algorithm knows that my channel is worth caring about. If you're curious about ecosystems, you could check out my episode on forest ecosystem design, which I'll link on the screen right here, or whatever the algorithm is recommending for you right now. Thanks again, and I'll see you soon for another episode of Just in Time World Building.